RKA4JL. This video explains Earth's geological structure, covering its internal structure, which is composed of the core, the mantle, and the crust, and then moving on to its external structure, or the structural macroforms, which are composed of the crystalline shields, the sedimentary basins, and the modern foldings in a succinct, objective, and lively way. So let's go. Hey everyone, how's it going? My name is Paolo, I'm a geography teacher, and welcome to Geo Illustrata. Our topic today is geological structure. Just so you know, we're going to start by talking about the internal structure of planet Earth, and then we'll move on to the external structure, that is, the structural macroforms. So without further ado, let's get to the video. I just ask that you stay with me until the end, so you don't miss any content, okay? Because this topic might seem a little complex, so it's important that you watch until the end. In this little diagram I drew, you can get an idea of how the internal structure of planet Earth is set up, and it basically consists of the core, mantle, and crust. Let's talk a little more specifically about each one of them, starting with the core. Well, the core is the central part of planet Earth. Consequently, it's the deepest part. It starts at a depth of about 2,900 kilometers, and it is mainly composed of iron and nickel because these materials are heavy and dense. So they end up sinking from the previous layers and reaching the core. Another interesting aspect of the Earth's core is that it is considered to be liquid in the outer part and more solid in the central core. This is due to the great pressure exerted in the central part of the core, which does not allow these materials to take on a liquid form. Well, now speaking briefly about the Earth's mantle, this is the layer that is located between the core and the crust, mainly consisting of dense rocks of intermediate density, being composed mainly of oxygen and magnesium, as well as iron and silicon. In addition, it also ranges from about 40 to 2,900 kilometers in thickness. Well, now let's move on to the one that is the most important for us in this video, which is the Earth's crust. Well, the Earth's crust, also known as the lithosphere, is made up of the continental crust and the oceanic crust. The first has an average thickness of 40 kilometers, while the second has an average thickness of 7 kilometers, which can vary depending on the location. The lithosphere is the most rigid layer of planet Earth, made up of rocks of different types and also of different ages. And it is extremely important for human beings because it is where natural resources, plants, and also many mineral resources are found. Even though it is so rigid and so important within the overall structure of planet Earth, it is also the thinnest layer, with a practically negligible thickness compared to the others. Because of this, it's common to make an analogy between the Earth's crust and an eggshell. Tell me, have you ever heard this analogy from your teacher at school? Probably yes, right? That's because the Earth's crust is to the Earth as the eggshell is to the egg. In other words, it's an extremely important rigid layer, but also extremely thin. In the case of the egg, the white and the yolk make up almost the entire egg. And in the case of planet Earth, the mantle and the core also make up almost the entire planet Earth. Well, when it comes to the general structure of planet Earth, it's important for you to know that only 4 elements make up about 90% of the Earth. As you can see in this chart that I'm showing on the screen, they are iron, oxygen, silicon, and magnesium. There are many others as well, obviously, but all in small percentages, all right? Now that you already understand what the main layers of planet Earth are, as well as their characteristics, let's move on to the planet's structural macroforms. But before that, if this video is helping you in any way, leave a like to support us. Also, leave a comment saying what you liked and what you didn't like. Share the video with your classmate. You know, the one you're sure hasn't done their homework yet or hasn't studied yet. Also, follow us on social media, especially on Instagram. I'm trying to get back to posting there. And if you're a teacher, we have our exclusive Telegram group, right? Which is a direct communication channel where we can talk and chat, all right? So without further ado, let's get to the end of the video. Well, about the macrostructural forms of planet Earth, you need to know that there are 3: the crystalline shields, the sedimentary basins, and also the modern foldings. Let's talk a little more about each one of them. Starting with the crystalline shields, which are also known as continental platforms or cratons. This is the oldest structure of the Earth's crust, and it is basically made up of crystalline or igneous rocks. In short, igneous rocks are those that result from the cooling of Earth's magma. I'm not going to explain in detail how this happens here, because I have a video here explaining it in more detail. It's an old video, but it's very well explained, so take a look at it later to understand better. I'll leave it here in the description. The crystalline shields are also very ancient structures, stable with little or no presence of volcanism or earthquakes. Besides that, it is also a relatively flat structure, mainly featuring low plateaus or even depressions. As for sedimentary basins, as the name suggests, they are formed by sedimentary rocks. These rocks, in turn, are formed from sediment particles that come from other rocks, such as igneous and metamorphic rocks. Okay, but how does that happen? It mainly happens through the processes of weathering and erosion, which wear down these rocks over the years. And these particles are gathered in sedimentary basins and over geological time form sedimentary rocks. I covered this clearly in the earlier video about rocks for anyone interested in learning more. As for their shape, sedimentary basins usually take the form of plains, plateaus, and also depressions. In Brazil, there are many sedimentary basins, but I'm going to mention three of the main ones here, okay? They are the Paraná Basin, the Amazon Basin, and also the Parnaíba Basin. Well, let's move on to the last one now, right? If you've made it this far, congratulations. I'm proud of you, all right? Let's go, modern fold mountains. Well, you need to know that this is the most recent formation on planet Earth. And when I say recent, I don't mean it happened the day before yesterday or last year. No, here we're talking about geological time, okay? So this formation happened around the end of the Mesozoic and the beginning of the Cenozoic, as you can see in this chart I'm showing on the screen. This chart briefly describes geological time. These formations are created through the process of orogenesis. What is that? It's the movement of tectonic plates coming together. And this movement creates the great mountains and the large mountain ranges. Because of this, modern fold mountains are the highest structures we have on planet Earth. Among the main modern fold mountains we have, I'll mention three again: the Andes Mountains, which are in Latin America, the Himalayas, which are in Asia, and the Alps, which are located in Europe. You must have heard of the Swiss Alps, right? All of these are modern fold mountains formed by the orogeny movement of tectonic plates. And that's why it's said that there are no mountains in Brazil, because our country is located in the middle of the tectonic plate. So there is no mountain building activity here, which is what results, after all, in mountains. It's true that we have large elevations here. However, they are the result of other processes. But that's another subject for another video. Well, this video was almost entirely based on the works To Understand the Earth, and also Geography of Brazil by Jurandir Ross. I'm leaving them here in the description for anyone who wants to learn a little more. Remember, to really understand this, you need to read. So if you want to understand better, go check out these works, all right? That's it. I'll stop here. Thanks to you who stayed with me until now. See you next time. Bye.